Let's learn about AC and DC conversion. So here I have a 120 volts AC to 22 volts DC converter. So first comes from the wall power, 120 volts, goes into a transformer. This transformer input 120 volts AC and outputs around 26 volts AC. Then this 26 volts AC goes through this bridge rectifier here, which then rectifies that 26 volts AC to 26 volts DC. I think this rectifier has some resistance, so instead of 26 volts, it comes out as 22, 23 volts DC, but it's just enough to power this drill motor. Here, when I turn this extension cord on, this motor will spin, spinning at 23 volts DC. So if that was 120 volts AC going through this motor, it wouldn't end well. But since it goes through our converter, 120 volts to 26 volts, and then AC to DC, it can spin safe. So let's dive deeper on how you can make one of these, how these connections work, and what is a bridge rectifier. So here I have my multimeter, and we're gonna measure what's coming into the transformer and what's coming out of the transformer. So first, I'm just gonna disconnect these alligator clips from my motor right here. So the green, in this case for DC, the green would be negative and the black is positive. There's my multimeter right there, and now I'll connect. This isn't really reliable wiring, but now I'll connect my positive to my positive probe and my negative to my negative probe. So here I have my multimeter connected. The probes are connected to the rectifier output, so it should be DC voltage should be around 23, 22 volts. So when I turn this power on, you should see around 23 or 22 on my multimeter. Yep, okay, 22, almost 23, 22.8 volts. So that is what's coming into the transformer, coming out of the transformer, and what's going through the rectifier, and what's coming out of the rectifier. So there you go, 23 volts. Just jumped up for some reason. Oh no, it's back at 22.8. So now I have my output of my transformer connected to my multimeter, and if I turn the transformer on, you can see 26, 25 volts around there. So this transformer transforms 120 volts AC to around 25, 26 volts AC. I was about to say DC, but it's AC. So on my multimeter, you might have noticed when measuring DC, I was on the DC setting, and when measuring AC, I'm on the AC setting. So that's sort of how you know if it's AC or DC. Just look at the settings I have. This is AC, that's DC, just in case you're curious. So here we have a close-up view of the bridge rectifier. So here our white is our neutral, and our black is our live. So our live would go here, and our white, right here, our neutral, would go here. And our bridge rectifier does consist of 4 diodes, as you can see. You can even see the little white marks on here. If you are building a rectifier on a breadboard, make sure these 2 diodes here, white marks facing this way, and these 2 diodes here, white marks facing this way. Also, don't mind this wire here. See, there's just nothing connected to it. It's just to hold in this copper wire I have here, this white wire. Same with this one, there's nothing connected to it. Just to hold in this black copper wire here. So let's go over the 2 outputs of our bridge rectifiers. We went over the 2 inputs right here. This is the neutral. Get confused. This is the neutral and this is the live. Now our two outputs are the positive and the negative. Since it converts AC to DC, it would be positive and negative. So here I brought in more wires to show you an example. So right here I'll sort of face it up. Right here is our positive output. So just between these two diodes here is our positive output. So this would be the positive DC. So in that motor example, I would have connected this this output to the positive of the motor. For now, we'll just connect our positive output to a blank space in our breadboard. But I will be using this motor again just to connect it all up and show you guys how it all works and what it looks like all put together. Here I'll use this green wire to connect our negative. Our negative is pretty self-explanatory. It's the other corner down here. Right here, just at the corner of these two diodes here. Right here. That's our negative output. And we'll just connect our negative output to a blank space in our breadboard. That, because we're not going to be using it right now, but we will be using it later. Now let's go over our transformer setup. Here are the 120 volts live and neutral. This one is the live, this one is the neutral. The white wire is neutral, black wire is live, if I haven't said that already. So we have our 120 volts AC connected to the primary of our transformer, and the secondary here is our output. So same thing, same thing as the input, live, neutral. Same thing at the output. This one is live, the black wire live here, and this one is neutral. So a pretty simple transformer setup. Primary 120 volts AC, and the secondary outputs around, as I said, 26 volts AC. So primary is 120 volts AC, and our secondary is 26 volts AC. AC, by the way, not DC, AC. Again, the transformer isn't the one that converts it AC to DC. The bridge rectifier is the one that actually converts it from AC to DC. The transformer just converts or transforms our 120 volts AC to 26 volts AC, which is a more reasonable voltage for our breadboard and our bridge rectifier. So now we know how this all works. Let's actually connect it to our motor here. So our two outputs here, our negative and our positive. What I'll do here is I'll just get some alligator clips. And first we'll connect our positive. So I'll connect our positive, also known as the red wire, on our motor. And take our positive out of our breadboard and just connect it up like that. So just make sure your wires don't touch other wires. So we're going to move this little guy over here and place our wire like that. Just make sure they don't touch. Just simple. Don't touch other wires, because you don't know what's going to happen. I never tried shorting AC and DC because I'm not going to do that. But I don't know what happens if you short AC and DC. My best guess is it's not good. So just don't do it. Just be careful. Especially when dealing with 120 volts AC. Be careful. It's not something you play with. It's not a toy. You don't go around shorting it everywhere. Just like this guy.
Go.
You don't go around doing that. Only Electroboom, only Medi can do that. So last but not least, we'll connect our negative here to our negative output of our bridge rectifier. So do make sure you hold your motor, because if it is loose at full power, it will start spinning around, going everywhere, tangling all the wires, and you will get a short. So just be really careful. You just hold your, if you are using a motor, hold your motor. Please just hold it. Don't put it on the desk like this or on your surface like this, because if you do that, it'll go spinning around, tangling all the wires, And if these two metal pieces touch, or if a positive touches a negative, especially AC and DC, you don't want that to happen. So here we have our motor. Turn it on. And there you go. It spins. DC voltage, around 22 volts DC. Sort of what a bridge rectifier is used for. Just converting AC alternating current to DC direct current. Now, how exactly does this bridge rectifier convert AC to DC? So on a scope, AC is more of a squiggly line, because AC alternating current alternates from positive and negative, positive, negative, positive, negative. But DC is either only positive or negative. So when you're saying positive DC, it's positive DC. When you're saying negative DC, it's negative DC. So what this does, it converts that squiggly line into a straight line. So basically converts this AC source in simple terms. I'm not going to go over the details and how it does it. I'm just going to explain. In simple terms, converts AC, which is the squiggly line, to DC, which is a flat, either positive or negative. So if you found this video helpful, information about bridge rectifiers, maybe subscribe, hit the like button if you want to see more content like this. If you're interested in kind of stuff like this, I have big plans for this channel, like Python, Lua, Python coding, Lua coding, electrical engineering, electronics engineering, all this kind of stuff. So if you're interested in this kind of stuff, subscribe, and I'll see you guys in the next video. Goodbye, guys.